and welcome to I Love Science. All of you must have seen or read some news articles that NASA sent a very large telescope in space on 25th of December. That telescope is called James Webb Space Telescope, or JWST in the short form, right? So we have created a small model of that telescope, and we will try to explain to you in simple terms on what will this telescope do, what are the different components of this telescope, how will they work, and what are the different technologies involved in operating this telescope. It was named after Mr. James Webb, who was the chief administrator of NASA in the 1960s, and he was responsible mainly for the design and the preparation for all the Apollo missions which went onto the moon. So first let's discuss what will this telescope do or what will it see. This telescope will be able to see very distant objects in space. They are so far away that it would take billions of years, not millions, billions of years for even light to travel from that place to our telescope. Which means that when this telescope looks at those objects, the information or the light received by this telescope would be many billion years old. That is why it is said that this telescope will work like a time machine, because it will be looking at those objects like old galaxies when before they were formed completely. They were in the process of forming many billion years ago. So that is why it is looking at the past. That is why it is also called a time machine. So now let's look at this telescope. The most attractive or stunning feature of this telescope is this golden mirror that you see here. You may have heard that in many telescopes we use mirrors so that we can gather a lot of light and we can see very faint or distant objects. But in this case, these mirrors are covered with gold. Now, what is the purpose that these mirrors are covered in gold? Because gold can reflect the infrared light most effectively, right? The normal mirror, which is coated with silver, cannot reflect infrared light properly, and this telescope has to look at the infrared light. So first let's understand what is infrared light, and then why do we need to look at the infrared light only. Normally, from our human eyes, we can see the visible light, which is, as you know, varies from red to violet in spectrum. Okay, where the red has the lowest frequency and violet has the highest frequency. Any radiation which has a frequency less than the red light is called infrared radiation. Now, let's see, why do we need to study infrared? Now, for that, you have to understand the concept that our universe is expanding, which means the distant places which are very far away from Earth are moving away from Earth. And when they are moving away, the light which comes from those objects to us gets red shifted, which means the visible light gets converted into infrared spectrum. And that is why to be able to see those objects, we need to be able to see in the infrared spectrum. Now, why does that red shift happen? That happens because of Doppler effect, which means that when an object is moving away from us, any radiation, whether it is sound or light, which is coming from that object to us, its frequency is reduced when that object is moving away from us. So let's look at these videos of a train and a car, where you will be able to hear the frequency of their horn or siren when they come towards the observer and then move away from observer. So in these videos, you must have observed that when the train was going away from the observer, then the sound or the pitch of the siren or the horn was of lower frequency. Now this is the Doppler's effect, and it applies not only to sound but also to any radiation or light which is coming from that object. Which means a distant galaxy or some object is moving away from Earth at a very high speed, the radiation being received by us will have the lower frequency, and that means the lower frequency means that that radiation will be in the infrared range. So that means we should be able to observe the infrared radiation to be able to see or view that object. Later, this radiation is converted into normal light frequencies so that we can view those images. So to be able to receive and observe the infrared light properly, these mirrors are covered in gold, because gold has a property that it can reflect the infrared light with highest efficiency. So when the distant light comes into these mirrors, it gets reflected from here, reaches these this secondary mirror which is on this side, and then again reflects from there, and then comes into this actual image sensor which is here at the center of these mirrors. Now let's understand these mirrors a little more. As you can see that there are these 18 hexagonal mirrors. Uh, each of these 18 pieces are made of a material called beryllium. Now this material beryllium was chosen because it is very lightweight and it is very strong, so that the total weight of this telescope should not be very high. Okay. Now let's imagine about the size of this mirror. Okay. Now this diagram will give you a better idea about the actual size of these mirrors. The total height of these mirrors is about 21.5 feet, which is approximately like a two-story building. You can also see that an average human is about this tall, right? And then you can take the idea that how big are these mirrors. Okay? So this is the total size of these primary mirrors that we have. In comparison, that you can see the primary mirror of the previous telescope, which was called Hubble telescope, was about this high, right? So now you get an idea that these mirrors, which in this model they look so small, but actually these are so tall that this is approximately the height of a two-story building. And each of these 18 mirrors, which are these golden mirrors that you see, have very small motors behind these, so that their orientation and angle can be adjusted properly, so that this whole device works like one single mirror, so that the light reflected from this mirror goes onto this secondary mirror and it is properly focused. So this was about the primary mirror and the secondary mirror of this. Now let's look at the other components of this telescope. You see this large box or the large unit behind these mirrors, right? This unit is called ISIM, or Integrated Science Instrument Module. Okay? This module has a lot of instruments which are used for processing these images in different radiation and frequencies. It processes those images, and then those processed images are transferred to the main computer, which is at the bottom of this telescope. Now let's look at this large silver kind of a sheet which you see, right? Now this telescope has these 5 large sheets of a plastic kind of a material, and these 5 layers have been created so that the light which will fall on this side, the bottom side of the telescope, the heat of that sunlight does not reach the main mirrors, right? Now why is that? Now since these mirrors are designed to process the infrared images, right? And you know that heat is also radiated in form of infrared. So it is very important that no other heat should reach these mirrors other than the light or the infrared spectrum coming from the distant parts. That is why these primary mirrors have to be kept very cold, and that is the reason of this sun shield or these silver plastic foils that you see here, so that the sunlight which will be coming from the bottom side of the telescope, the heat of that sunlight should not reach these primary mirrors. Okay. Now let's look at other scientific components which are at the bottom side of this telescope. Okay. Now what you see here is there is one large box which is called the main spacecraft bus. This spacecraft bus has the main computing equipment for the telescope. You also see these solar panels. These solar panels will receive the sunlight and they will generate about 2 kilowatts of power, which is required for all the computers and communication equipment which are on board this spacecraft, right? Uh, this this spacecraft bus also has some thrusters, which means these are small controlled rockets onto this spacecraft bus, which will help in changing the direction of the spacecraft so that we can adjust the orientation of the primary mirrors so that we can look at different directions in space. Okay. It also has the communication equipment because it has to constantly communicate with Earth. So that is why you see there is a communication antenna or the high gain antenna which is there on this, and using this antenna it will communicate with the NASA Earth station and all the data can be received onto the Earth station. This spacecraft bus also has the thermal control system which will be required to do the required cooling onto the equipment so that it doesn't get overheated. So overall, this telescope can be seen to have two sides. Okay? This side is called the cold side, which means it should not have any external heat. And this side is called the hot side because this side will be receiving all the sunlight. And these 5 layers of silver coated plastic will make sure that the heat from this side does not get passed on to this side. Now let's understand that where in space will we put this telescope. That place is called Lagrange point. So as you can see in this diagram, at the center is Sun, and as you can see this green spot, this is the Earth which is orbiting around the Sun. Then there is Moon which is orbiting around the Earth. This telescope will be kept at this place which is called L2 Lagrange point, and it will be rotating in such a way that Sun, Earth and Moon will always be in this direction, and the uh, telescope, JWST telescope, will be orbiting the Sun like this, so that all three objects, Sun, Earth and Moon, will be behind it. This particular point will help that Sun will always be on this side of the telescope, and this side will never get very hot. Another benefit of the Lagrange point is that it provides a place where this telescope can keep moving here like a satellite, because the combined gravity of Sun, Earth and Moon will provide the gravity pull on this side, and the centripetal force will make sure that it can keep moving in this orbit without spending too much energy or too much fuel. So with minimum fuel, it will be able to keep orbiting this place like this. So this was a quick introduction which we tried to simplify for you to understand this very complex and technically advanced telescope. This telescope was built in more than 25 years by thousands of engineers of NASA, and this is the latest technology marvel that we have. All the astronomers or all the science community is expecting it to send us very special pictures from the past of our universe so that we can understand our universe in a better way. So that is all for this video. Please do like and share this video and subscribe to our channel so that you never miss any future video that we will be posting on this. Thank you. Bye bye.